Global trade appears chaotic. On the floor of a commodities exchange, thousands of transactions execute in fractions of a second. But this velocity follows a rigid logic. Beneath the noise lies an invisible architecture governed by mathematical laws, the forces of supply and demand. To analyze these forces accurately, we have to strip away real-world variables and isolate our study within a specific theoretical environment. Economists call this the perfectly competitive market. This environment relies on two unbreakable conditions. First, the goods offered for sale are exactly the same. Second, the buyers and sellers are so numerous that no individual holds any market share. Because no single entity has influence over the whole, every participant is a price taker. A price taker is an individual or company that must accept the prevailing prices in the market, lacking the volume to influence them. Market structure dictates an entity's price-setting power, a relationship revealed by the spectrum of competition. On this diagram of market structures, the baseline is perfect competition. Here, power is completely decentralized and diluted among the masses. At the opposite end of the power spectrum, we find monopoly. A monopoly is a market condition where there is only one seller. That isolation grants them the power to dictate the price of a good or service. By isolating our model to perfect competition, we eliminate individual corporate power from the equation. This allows us to measure the aggregate mechanics of consumer demand in its purest form. The study of consumer behavior begins with the law of demand. This law dictates a rigid inverse relationship. Assuming all other things are equal, when the price of a good rises, the quantity demanded of that good falls. We can track this relationship by isolating a single consumer. Let's look at Catherine and her theoretical appetite for ice cream cones. This is a demand schedule. It catalogs Catherine's purchasing limits across various hypothetical price points, ranging from $0 up to $3. To visualize the underlying function, we translate this raw data onto a Cartesian plane, a coordinate system that specifies each point uniquely by a pair of numerical axes. First, we plot the limit of her price tolerance. At $3, she refuses to buy, demanding exactly 0 cones. As the price drops to $2, her quantity demanded expands to 4 cones. Tracing the path between all hypothetical price points reveals the downward-sloping individual demand curve. The model transforms individual purchasing intent into a predictable path on a graph. In macroeconomics, market demand is simply the sum of all individual demands combined. If we expand our microeconomy by introducing a second consumer, Nicholas, he brings his own unique price tolerances. We can calculate the mathematical aggregation of these two consumers at a specific price point, $2. At this price, Catherine demands 4 cones and Nicholas demands 3. Therefore, total market demand equals 7. The formal economic term for this addition process is horizontal summation. On the graph, the individual's distinct quantities add together along the horizontal x-axis to create an aggregate coordinate. By repeating this horizontal addition at every price point, we map the final market demand curve. The market is the horizontal arithmetic of its participants. This curve forms the baseline against which all economic shocks are measured. Analyzing market forces requires distinguishing between price and demand. A change in the price of the good itself does not alter the underlying demand function. Price changes cause a purely endogenous movement, an internal reaction that alters the quantity demanded along the established path. We can use a theoretical potato market to visualize this boundary. Increasing the cost of potatoes from $3 to $4 forces consumers to retreat up the existing line, reducing the quantity demanded from 6 to 4. The market's structural appetite remains identical. The line does not move. Consumers are simply constrained by a higher price. If altering the price cannot change the underlying curve, what mechanisms cause a market to structurally expand or collapse? These changes are caused by exogenous variables, external forces operating outside the price of the asset itself. This graph captures a structural expansion in the global market for coffee beans. At the same $1.50 price point, the quantity demanded has increased. The cause of this shift is a surge in the overall population of consumers. An increase in demand is visualized as a physical rightward shift of the entire functional curve. Conversely, An exodus of buyers causes a decrease in demand, shifting the entire curve to the left. Market shocks result from structural changes in the environment surrounding the asset. These exogenous forces can be organized into the acronym BITER. These are the 5 factors that hold the power to shift a demand curve. The first 4 variables are changes in the number of buyers, consumer income, shifting tastes, and future expectations. The final variable is related goods, which splits into 2 categories, substitutes and complements. Substitute goods can be used in place of another, like Coke and Pepsi. An increase in the price of one shifts the demand curve of its rival outward. Complementary goods go well together, like peanut butter and jam. If jam becomes unaffordable, the demand curve for peanut butter collapses inward. A demand curve is rarely static. It is perpetually held in suspension, vulnerable to being pushed or pulled by these external forces. The architecture of demand is an aggregate mathematical function governed by price and shifted by external BITER variables. But this model only dictates what buyers are willing to do in a theoretical vacuum. The demand curve alone cannot identify the actual clearing price of an asset. Identifying that price requires the construction of an opposing force. This requires accounting for quantity supplied and the law of supply, the producer side of the equation, governed by costs and profit motives. Consumer desire is only half the battle. Predicting a market's movement requires analyzing the mechanics of those who control the supply.